What's up, everybody? Obviously I'm not here, and today what we're going to do is look at lesson 1.2c, solving linear equations with different solving outcomes. So what I would like you guys to go ahead and do is go ahead and take out your notes. Take notes just as if I was in the classroom, and then when we were all done, you guys can go ahead and get started on your homework. Now remember, with the videos, you can pause and rewind it. So yeah, let's get going. So, first thing, it says a solution to an equation is a number that makes the equation true when substituting in for the variable. So what this mean is, imagine I have something like x plus 3 equals 7. It is saying there is one and only one number that I can plug in for x to make this a true statement. And to figure that out, we would just subtract 3 on both sides to get x is equal 4. That means the one and only one number I can plug into x would be 4 to make this a true statement. And lo and behold, 4 plus 3 is equal to 7. That's all this is saying. But now it's saying we're looking at stuff with special outcomes. So it says use the model to complete the following. So when I look at this, what do we observe? Now I know we haven't been looking at a lot of models this year, but I really want you to look at this. This is saying I have 2x's with 6 constants. This also says I have 2x plus 6 constants. And what can we observe about this? Well, I can observe that there is the same amount of x's and constants on both sides of the equation. Essentially, the equations are exactly the same. So let's look at what happens when I solve. So write the algebraic expression. We kind of already did this on the previous one, so let's go ahead and do it now. I have 2x's plus 6 constants, and I will set that equal to 2x plus the 6 constants. Explain in words what happens when you solve for the equation. Well, let's go ahead and do this. So the first thing what I would want to do is get the x's on the same side of the equation sign. So I have 2x on the right, 2x on the left, and what I would do is I would subtract 2x on both sides of the equation sign. And then I would be left with 6 equals 6. Now what I want you guys to realize is when the x's are canceled out, meaning there are no more x's and I'm left with just constants, you're going to have two solutions, either infinitely many solution or no solution. And it depends if I get a true or false statement. This is true. So what happens, explain in words what happens when we solved. We eliminated all x's, and had equal amount of constants on both sides. Equal amount of constants on both sides of the equal sign. Okay, now when that happens, I get infinitely many solutions. So what about the structure of the equation led to that solution? And it's because I had equal amount of x's on both sides. So it's kind of like, think about this. I have two twins. Will the twins always be the same exact age? Yes, they will. What if I doubled their age? Will they have the same age? Will they be the same age? Yes, they will. What about if I doubled their age and waited additional 6 years? Yes, and that's exactly what this is saying. So no matter what age these twins are, they will always be the same age. So what about the structure of this equation led to the same solution? And the structure is saying, basically when I look at the left side and right side, they're exactly the same. So one, they have the same amount of x's, have the same x values, or same amount of x's, and same constants. That's what led for them to have infinitely many solutions. So now let's look at this, guys. This is kind of like comparing, before we look at this example, I just want you to picture this. So if I compared my age to you guys, basically, how old you are, I am 20 years older than you. Okay? So Julian, however old Julian is, I'm most likely 19, 20 years older than him. So if this is me, this is Julian, would Julian and I ever be the same age? No, the reason why is because I'm always going to be 20 years older than him. So no matter how old Julian becomes, I will always be 20 years older than him. So let's go ahead now and look at this. So go ahead and write this down for me. What do you observe? Well, we have the same amount of x's. Same x's on both sides. But different constant. So let's go ahead now and look at this. It says write the algebraic expression for this model and explain in words what happens when we solve. So this would be 2x plus 8. This would equal then 2x plus 4. Now when I go ahead and solve this, I'm going to subtract 2x on both sides. And this would leave me with 8 is equal to 4. Now this is not a true statement. It's a false statement. When you solve and there are no more x variables, all the x's go away. Remember, I'm either left with two types of solutions. Either no solution, it's not possible, it's never going to happen, or infinitely many solutions, meaning no matter what happens, they'll get a true statement. In this instance, it is a no solution, and that was because my x values were exactly the same, but my constants were different. So what about the structure of the equation that led to the solution? As we just said, we had the same amount of x values, but constants were different. Okay. All right. So what observation can you make here? Now, really quickly, guys, I don't know what happens, but after this lesson, students think there's only two correct answers, infinitely many solution or no solution. This is not true. Up until this point, every time we solve for x, x has always had a solution. That would look something about this one, like this one. What do you notice about this equation? Well, on the left side, the x's are 2x, and on the right side, there's 1x. So what do I notice is the x's are not the same on both sides of the equal sign. So the x values are not the same on both sides of the equal sign. So for instance, like right here is the equal sign. So on the left side, there's 2, and on the right side, there's 1. Now, when this happens, there will be a solution for x. So x will equal 5, x will equal 2, x will equal 0, something like this. So there will be a solution. All right, let's go ahead and see exactly how this looks like now. So write an algebraic expression. This would be 2x plus 2, which would equal x plus 2. Now let's go ahead and get the x's on one side of the equal sign by subtracting x on both sides. These would be eliminated, and I would be left with x plus 2 is equal to 2. Take away 2 on the left and the right side to get x is equal to 0. And that's my solution. All right, what about the structure of the equation that led to the solution? And it was because they had different x values on each side of the equal sign. So different x values on both sides of the equal sign. All right now. So let's go ahead now and look at the next one. And now what we're going to do is jump right into solving these. So remember, on these I'm going to have 3 answers. The first one is what we've seen up until this point. X will have a solution. X will have a solution, such as x equals 2, x equals 1. That's my first example. My second example will be no solution. And that's what, no matter what number I plug in, it will not be a true statement. It will always be false. And my last and final example would be infinitely many solution. And that's when I solve it, and I end up with a true statement, such as 0 equals 0, 2 equals 2, 5 equals 5. And that means no matter what number I plug in for x, I will end up getting a true statement. So really quickly, just so you know, this would be when my x's are eliminated. For a no solution, I left with something like 7 equals 0. And infinitely many solution would be something like 5 equals 5, 0 equals 0, 2 equals 2, something like that. So let's go ahead and look at this. I have x's on the right side, I have x's on the left side. So when I subtract 5x onto both sides, I would be left with negative 2 is equal to. Students sometimes get confused here. If I have 5x and I take all of my x's away, I'm left with 0. There's nothing left. Now I look at this. Is this a true statement? Does negative 2 equal 0? And this is false. When that happens, this means it is a no solution. It is not correct. All right, then, looking at the next one. Now this starts to look a little bit more confusing because it's not exactly clear if it's one solution, no solution, or infinitely many solutions. I actually need to solve. So I'm going to begin by distributing here. This will give me then 6a minus 24 is equal to 6a minus 24. Now some of us might see that the equations are exactly the same. When the equations are exactly the same, that means I am going to have infinitely many solutions. Just think about it. The left side is completely the same as the right side, and therefore, since they're exactly the same, any number I plug in for a will lead me to have a true statement. So, if you recognize that right then, you can stop and just write infinitely many. Remember, guys, infinitely many just means no matter what number I plug in, I'll get the same answer. So let's go ahead and see if I solve this. If I minus 6a minus 6a, my variables cancel and I'm left with negative 24 equals negative 24. I have no more variables and I'm left with a true statement. That's how you know it's an infinitely many. Sometimes students don't see that right here and they add 24 on both sides. They get a little confused. Well, negative 24 plus 24 is 0. Same over here is 0, and that is also a true statement. All right. Now over here, I want you to know, notice I have 5m on the left side, 3m on the right side. Since I have a different amount of m values, I will have a solution here. So what I want to do is I want to minus 3m on both sides of the equal sign, and this will lead me with 2m plus 2 is equal to negative 8. I subtract 2 to get 2m is equal to negative 10. And when I divide both sides by 2, I'm going to get m equals negative 5. And ladies and gentlemen, this is just like what we've seen. Every question up until this point has been one of these solutions where it's been a one solution. So negative 5 is the one and only answer I can plug in for both m's to get a true statement. So let's go ahead now and look at this one. I go ahead and I subtract 8x minus 2x, which is 6x, plus 4 is equal to 6x minus 1. Now my goal is for you guys to look at this and recognize what kind of solution is. Is it a one solution, no solution, and infinitely many solution? Remember, the rule states when I have the same amount of x values on the left and right side, but I have different constants, this will give me a no solution. So in this instance, my x values are the same, my constants are different, so I already know this would be a no solution. Now for some of us who don't recognize that right away, let's solve it and see why that's the case. If I were to subtract 6x on both sides of the equal sign, these would eliminate and I would be left with 4 equals negative 1. Since I have no more x's and I'm left with a false statement, I would know that is a no solution. And for whatever reason, sometimes students go one step further. There's no need to do this, but I just want to show you. To get 5 equals 0. This is also a false statement, so it would also be a no solution. All right, so let's see. I would like you guys to go ahead and try the next two. So pause it right here. I want you guys to go ahead and solve these two and then determine if it's a one solution, no solution, or infinitely many solution. All right, guys, you should have solved number 8 and 9 already. So let's go over 8 and 9 and see what the answer is. So there's nothing I can do on the left side, but I can distribute this 3 inside here. This would give me 6a minus 3 is equal to 6a minus 3. Right off the bat, I can notice that the two equations on the left and the right side are exactly the same. So no matter what number I plug in for a, it would be a true statement on both of those. When that is the case, I know it's going to be an infinitely many solution. So I already know all real numbers. No matter what number I plug in there, I would get a correct answer. But let's say I continued solving this and I wanted to double check and I didn't see it here, which is no problem. We would minus 6a onto both sides. Those would be eliminated, and I would be left with negative 3 is equal to negative 3. This is a true statement. Negative 3 does equal negative 3, so it would be infinitely many solutions. Also, I don't know why, but sometimes students continue going and they just want to see what happens if I add 3. That would leave me with 0 equals 0. And that is also an infinitely many solutions because it is also a true statement. Okay? All right, so let's see if you guys did this one right. Few things we can do here. We can either distribute the 1/2 to the x and to the negative 4, or since this has an equal sign, I can do the fraction buster here. So to do the fraction buster, what I would do is I would look at this 1/2, and I would just multiply each and every term by 2. Remember, terms are separated by plus, minus, and equal sign, and even though that there is a negative sign inside the parentheses, this is all one term because the 1/2 and the parentheses has a multiplication in there. So these would cancel, and I would left with x minus 4 is equal to 4x plus 4. I want you to notice I only have one x here and I have 4 x's here. When the x's don't match, you will have a solution. So I would start by minusing x onto both sides, which would give me negative 4 is equal to 3x plus 4. I would then subtract 4 on both sides to have negative 8 is equal to 3x. And when I divide both sides by 3, I'm left with x is equal to negative 8 over 3. All right, so there you go. So let's go ahead and move on to the next one now. It says directions. Examine the structure of each equation by simplifying both sides first. State if there are any infinitely many solutions, no solutions, or one solution. If there is one solution, solve the equation and state the solution. If there are infinitely many solutions or no solutions, justify why using the structure of the equation. So right off the bat, let's go ahead and look at this one. First, what I'm going to do is distribute this 3, because I can't really tell by the structure of the equation at the moment. This would then give me 63e minus 9 is equal to 16 plus 63e. Based off just the structure of the equation, I know this one is a no solution because they have the same amount of e's, but they have a different constant. Okay? When the constants don't match, when the e's are the same, that would give me a no solution. If you still don't see that here, what you'd want to do is subtract 63e on both sides of the equation sign. Those would cancel, and I'd be left with negative 9 is equal to 16. That is a false statement, so that would be a no solution. And where it said justify, it's because the e's matched, but the constants did not. All right, moving on to the next one. Here I look at these and I say, okay, can't really tell what's going on here, so what I'm going to do is multiply. I look at the 2 and the 4. The LCM of 2 and 4 is 4, so I'm going to multiply both numerators by 4. All right, 4 times 1/2 is 2. And then I'm going to have the entire parentheses, x minus 2, plus 4 divided by 4. Oops, I put plus. Let me erase that because it is an equal sign. Those reduce, and I'm just left with negative 4 plus 2x. When I distribute these, I'm going to have 2x minus 4 is equal to negative 4 plus 2x. Once again, let's look at the x's. Those match. When the x's matches, my solution will be infinitely many solution or no solution. And the way to determine that is to look at the constants. Since the negative 4's are the same on both sides, it would be a infinitely many solution. The equations are exactly the same. And once again, if you did not see that, you just subtract 2x on both sides. Those would eliminate, and I would be left with negative 4 equals negative 4. That's a true statement, so it would be infinitely many solutions. All right, on to the next one now. Over here, same idea now, guys. What I would do is I would multiply both sides by 2. Those would cancel. I would be left with x plus 3 is equal to 5x minus 4. I want you to notice this one will have a solution. I can tell because on the left side there's only 1x and on the right side there's 5x. So what I would do is minus x on both sides of the equation. This would give me 3 is equal to 4x minus 4. And then what I would do is I would add 4 on both sides of the equation to get 7 is equal to 4x. My last and final step is I would need to get x by itself by dividing both sides by 4. Now, I knew this one had a solution. I didn't know what it was, I just knew it had a solution, one solution I should say, because when I simplified it, I knew that there was 1x on the left side and 5x on the right side. Since the x's did not match on the left and the right side, I knew there would be one solution when I solved. All right, looking at this one now. It's a little too crazy to figure out what it is, so I need to begin solving for it. I would start by distributing not just a 3, but a negative 3 to each term. This would be negative 3a plus 6 minus 2a is equal to negative 5a plus 9. I look on the left and the right side, and it says negative 3a minus 2a is negative 5a plus 6 is equal to negative 5a plus 9. Now, right here, my goal, guys, is at this point that you can start to see the structure of the equation and realize if it's one solution, no solution, or infinitely many solution. Remember, I do that by double checking my variables. I have negative 5 on the right, negative 5 on the left. They're the same. So I'm either going to have no solution or infinitely many solution. And I can determine that by looking at the constants now. So when I look at the constants, this has a 6 and this has a 9. Since they are different, since they are not the same, this would mean that infinitely many solution is not possible, and this one would actually be no solution. The right side is always going to be 3 more greater than the left side. Now one more time, let's say I didn't understand exactly how that works, and I wanted to go ahead and solve it. What I would do is I would add 5a onto both sides of the equation sign, which would give me 6 is equal to 9. And if I subtracted 6 on both sides, which that step is kind of unnecessary, this would give me 0 equals 3. Doing good. How are you doing?
Good.
Just making the video for the kids tomorrow.
Nice, man.
All right. So that would be 0 equals 3. And since that is a false statement, this would be no solution. All right, guys, so let's go ahead and look at this one. This one looks a little tricky. What we need to do first now is distribute distribute the 12 in here into both of these, and distribute the 8 into both of these. This would give me 12 over 3x minus 12 over 2 is equal to, now we're going to do it on the right side, 8 over 2x minus 8. Now let's go ahead and simplify these. 12 over 3 is 4x minus 6 is equal to 8 over 2, which is 4x minus 8. From here, guys, now I look at my x's on the left and the right side. They are the same. So I know that my two solutions will either be no solution or infinitely many solution. If the constants are the same, it would be infinitely many solutions. If they're different, it would be no solution. So let's go ahead and see. If I subtract 4x onto both sides, these get eliminated. I'll be left with -6 equals -8. This is a false statement, so my answer would be no solution. All right, so now we got a decimal buster here. So what we're going to do is multiply each and every term by 10. Distribute that to each and every term. And this would give me 25n minus 6 is equal to 24n plus 28. Now, right off the bat, guys, I want you to tell that this is a no solution, this is a one solution because the amount of n's are different. Since the amount of n's are different, I will be able to solve it. So what I'm doing is I'm going to subtract 24n on both sides of the equation sign to give me n minus 6 is equal to 28. And then I'm going to add 6 to get n is equal to 34. So if I plugged in 34 into that, I would get the correct answer. All right, guys, almost done here, so let's keep rocking and rolling. So number 16, tricky one, guys. I have a negative in front of the parentheses. Remember, whenever there's a negative in front of the parentheses, it's like an invisible -1. What I would do is distribute the -1 to each and every term on the inside. This would give me 13 minus 4a minus 8 is equal to 5 minus 4a. Really quickly, I want you to notice -4a, -4a. That's great. I will either have a no solution or an infinitely many solution. So to determine that, let's first look on the left side and combine like terms. 13 minus 8 is 5 minus 4a is equal to 5 minus 4a. Hopefully you guys notice that the equations are exactly the same. Whenever the equations are exactly the same, it is infinitely many solutions. Since it is infinitely many solutions, that means no matter what number I plug in for a will result in a true statement. If you want to keep solving, we would add 4a onto both sides. Those would cancel, and I'd be left with a true statement. Remember, when there is no variable and you're left with just constants, it is either infinitely many or no solution, and you can determine if it is a true or false statement. Since it's true, it equals an infinitely many solution. All right, over here now. Two things. You can distribute the 1/3 or you can do a fraction buster. I like doing fraction busters because I'm not a big fan of fractions. So if I multiplied both sides by 3, these would be eliminated, and I would have 6 over x, 6 take away x, is equal to 12x plus 3. Now this one is, you can see it will be one solution because I have -1x and 12x. So what I would do is add x onto both sides to get 6 is equal to 13x plus 3, minus 3 to get 3 equals 13x. And I would divide both sides by 13 to get x equals 3 over 13. All right, now here it says consider the expression 4a minus 12. Write a different expression that is, if set equal to 4a minus 12, would result in the equation have infinitely many solutions. So basically, I want you to have 4a equals 12. 4a minus 12 equals to another expression that, when simplified, would give a infinitely many solutions. Now remember, infinitely many solutions means you need to have the same variable and same constant. So you would need to get something to get like 4a minus 12 as your final answer. So let's think of ways that I can do that. I want you to try to come up with one on your own that when you simplified gave you 4a over 12. So here is my example. I want you guys to come up with your own. If you had something like 4 times a minus 3. If I distribute that, I would get 4a minus 12. something like that. So I would like you guys to do something like that where it would result in the same answer. Okay, let's go ahead now and look at this one. Now let's say if I have x plus 1, I want you to come up with one where it would be no solution. Remember, no solution means that it is the same x values, different constant. So go ahead and pause this, come up with your own, and then when you're done, compare it to mine. All right, guys, so looking at this one, if I had x minus 2, that would result into a no solution. The only thing is the x's must be the same, and the constants must be different. So this could be a -2, -3, 5, 7, 12, whatever it could be. Just cannot be a positive 1. All right, consider the expression 2x plus 6. Write a different expression that if set equals to 2x plus 6 would result in having one solution. Now remember, one solution needs to have just one rule, different x value. Different x value. So if this is 2x plus 6, this can be anything except the x needs to be different. So anything but 2x. So it could be 1x, 5x, 2x. So if I had like 5x, and this plus 6 doesn't matter. The constant doesn't matter for one solution. It can be anything. So I'll put minus 8. Okay? So if I were to solve this, I would subtract 2x on both sides to get 3x, and then I would add 8 onto both sides. And that would equal 14. When I divide both sides by 3, I would have x equals 14 over 3 as my final solution. Okay? All right, what about the structure of the equation that leads to one solution, infinitely many solutions, or one solution? Complete the table below and provide examples to support your claim. So we talked about this over and over and over. So hopefully it makes sense now. But we're going to put it down on paper, and I'm going to have you refer to these notes. So what it says right here, a one solution. The structure of the equation will have different x values on both sides of the equation. So we'll have different x values on both sides of the equation. The constant doesn't matter, okay? It's just different x values on each side of the equation. Let me double check what the last one is. Equation model. Okay, so let's go ahead and look at this then. The structure of a no solution is same x values and then different constants. That's like me and Julian, what we talked about. Same x values, but I'm 20 years older than Julian. And then infinitely many solutions is same x values, but different x values and same constants. So if we thought about our twins, Zach and Avery, whatever their ages are, they're exactly the same. In 3 years, their age will be exactly the same. If we doubled their age 3 years from now, their ages will be exactly the same, because since they were born on the same day, no matter what I do to one, I'll have to do to the other. All right. Now the modeling, since we haven't been really focusing on models, I just wanted to go really briefly. If I had my x values, it would have different x values. And then remember, the constants wouldn't change. It's just the different x values. No solution would be same x values, but it would have different constants. So this would like be 1, 2, 3. This would be like just 1. It's that part, the same x values on both sides of the equation sign, different constants. And infinitely many solutions would be exactly the same. So 1x, at the same exact equations. 1x, and then like 1, 2, 1, 2. So exactly the same on both sides. We're more focused about the equations. So if I have 3x plus 7 is equal to come up with an equation with one solution, I would just need a different x value. So like negative 2x plus 4. Constants don't matter, it's just the x values with one solution. No solution, same x values, so like 2x plus 6. Now for it to be no solution, the x values must be the same and the constant needs to be anything but 6. So like minus 1. Could be anything, it just cannot be 6. And then finally, for infinitely many solution, it has to have the same x values, so it's 3x plus 5, and the same constants, so something like 3x plus 5. Remember, it won't always be that easy. If I have something like that looks like 2x plus 4, it might look like 2 times the quantity of x plus 2. So when you distribute and simplify, you will get the same answer. Alright guys, hopefully you're still awake after watching this video. You guys can go ahead now and start your homework. When you're all done with the homework, if you finish, please just be good for the sub, work on something, work on your quiz corrections, work on the homework, all that good stuff. You guys should have plenty of stuff to work on. If you still have questions, please feel free to email me, and I'll be more than happy to answer any questions you guys have. Alright guys, I will see you next time.